Thank you very much for listening to this part of the presentation. The goal of this part is to try to explain how can an integration of Bonita with TCPS provide a powerful solution. It will take about 15 minutes. Currently I am concentrating on decisions in decision gateways, but I am sure that task distribution and the authorization could be also an area of cooperation. We have seen the isAllow function of TCPS that delivers true or false. Now I want to show how can we use the get condition to allow function in gateways with multiple branches. If we know exactly some of the decision attributes and we are curious what conditions should be fulfilled for the rest of the decision attributes, then we call get condition to allow for the rule. Get condition to allow delivers a logical expression in disjunctive normal form. If we deliver only one query decision attribute, then in many cases we will get a list of discrete values that would make the rule evaluation to true. This is a simple process where some decisions will be made automatically by evaluating a business rule that we have shown previously. Sometimes it's enough that rules deliver clear yes or no, but sometimes we need also other branches, for instance, as no, go for manual decision, as you see here. This pattern ensures a great optimization potential by fine-tuning the decision rules, iterating frequently. If a manual approval is needed, we go to the make decision human task. In this task, we can decide if the deal can be accepted or not. The OK and not OK human tasks are only for the reason that the process can stop here and we can check easily if the flow is as we want it. For this process, we define a BDM with loan request data type consisting of loan amount, customer segment, risk, and decision. The decision is a string, not a Boolean. Field request form is generated by Bonita based on the contract for sake of simplicity. Loan amount, customer segment, and risk will be entered here. Validate request is a service task in that the Con4a connector will be called, which is a TCPS connector. That you see everything very quickly. This is the BDM definition. This is the contract for process start. This is the definition of variables used in the process. And this is how we initialize the process variable. Now we would switch to the live process, and probably you would remember the case Zolti tested previously using the TCPS rule center. Now let's enter it here. Amount 900, as you see, customer segment 1, and risk as 0.19. Click start, be excited. Hopefully we got a task to execute. It's absolutely okay as we accepted. Execute this task. Sorry, take the task. And execute it. Now let's see the process diagram. In this case, it means that the process took this part for execution from the G1 gateway. Let's find out why. I show you this branch. This branch will be taken if approved Boolean is true, as you see here. Now you see what happens in the validate task before ending. the booleans that we use in gateway 1, for decisions will be set here. For instance, we see that the validate request task will set approved boolean in this form according to the value of the decision data member of the loan request object as you see here. So let's have a look at the connector that was called before entering the service task. Probably you would guess that the connector was responsible for setting the decision data member of the BDM that we have seen just now. The execution tab here, you see this connector definition, and now I propose we have a look at the definition of this connector. As you see here, the connector definition has to have an input variable of type Java util map that is appropriate for the connector. The connector accepts key value pairs where the key is a string and value is a string array. Key contains the name of one TCPS decision attribute, and string array the value of the attribute. Because of multi-value attributes, we have to provide a string array, but in all cases, it will contain only one string. Let's go to the wizard. And we see that according to this definition, this variable should be inputted by a script. It will be a Groovy script. That means this script can vary by process definitions. This feature of Bonita is great and enables us to develop a single or very limited number of connections only. Let's check further. The output that the connector will provide is a string called con_decision. I come back to the handling of con_decision later. In fact, con_decision should be a string array, but for sake of simplicity, I defined it as a string. I can explain everything this way also. Let's go back to the validate task and see how that will use the connector. You see that as an I was too quick. That we define here really the script, not that it should be a script, but the concrete script, how to provide the entry variable for this connector. You see that we provide the script, and this is a map object that we create here. This script would be eventually different for each process pool and each TCPS rule, but would be very similar to this one, I guess. Okay. Now, let's have a look at the output operations. In the output operations, the connector output con_decision will be saved in the loan request BDM object using the method that is provided by Bonita automatically, the set decision. This is the whole picture, and I think it's really very simple. Okay, let's try two more scenarios. Let's take the value for the amount this and risk. Okay, what do we accept here? You remember probably that the maximum amount for customer segment 1, 2 and 3 was 1,200. That's we are expecting here in refusal. Let's see the tasks. Okay, and we landed in notify no. That means it was refused without any human task, as you see here. I guess the change that Zolti made regarding customer segment 6 is already in action. That means if we try it, then we should have a manual task in this case, regardless the amount that we are requesting and regardless the risk that the customer has. Okay, tasks. Got it, and we landed in make a decision as we expected. That means the process and cooperation with the rule is working. I have to mention that in this last scenario, I haven't had to enter really the risk and the loan amount, because as you remember, in case of customer 6, it comes anyway to manual approve. But I can't show it you in the process now, because I defined the contract that way that I always have to enter the other attributes as well. That's why I try to show it in the rule center. Try the following scenario with customer segment 6. And the query data is decision, as we do it in the process also. The only difference is that here we do not specify values for loan amount and risk. You see that the result is the same. That's what we wanted to show. Now I hope I can explain what I meant before by avoiding fraction rules. Let's assume we have entered in the process loan amount as first, and customer segment and risk will be determined in later tasks. Can I tell the customer in the first task anyway that he has a chance for automatic approval or not? Let's invoke the rule. You see, we have a chance to be approved automatically, because the rule contains a limit for 2,000 approved if we have not specified the customer segment yet. Okay, but what if we take the value 2100, then we have no chance to be approved automatically. Now let's assume that we arrived in the process to the point that we know already that the customer belongs to the segment, let's say 2. Okay. And we ask the rule in this case, and of course there is no chance anymore, because for customer segment we set a limit with 1200 with manual exception. Okay, let's try with 1100 and we see it's manual approve possible. Let's go back to the presentation to explain a little bit more. Okay, these are the already well-known declarative predicatives, and let's assume the business case. The business case is what is the maximum requestable loan amount that can be approved automatically. Okay, if we couldn't evaluate our business rule because the customer segment and risk info is missing currently, then we should implement a part or fraction business rule like this. If loan amount greater than 2000, then tell please decrease loan amount if automatic approval wanted. Okay, but in a later task we would arrive to the stage where we already know the segment information, but the risk is not available yet. Then we would have a question: what is the maximum requestable loan amount that can be approved automatically when customer segment is 2? Then we would got another small part of the business rule, and we would say if loan amount greater than 1000, then tell decrease loan amount, etc. Okay, I hope this is now clear that in this case, if we cannot handle other way the business rules, then we would got some more rules and some redundancy. Now finally let me speak a few words about the TCPS connector for the near future that could be developed let's say in a month. You have seen this screen several times during this presentation. This is our classic example with customer segment 1, amount 900 and risk with 0.19. We got this case approved from the connector, but as you see, the response of TCPS contained approved or manual approved. Because in this logical context, approved implies manual approved, I have simply ignored manual approved in the connector in this case. As you see here above, TCPS is generally aware of logical implication for the primitive data types. It's a great thing. If the statement says risk less than 0.3, this implies risk 0.4, and TCPS can handle it. But in custom cases, as now, it's unfortunately hard-coded. I'd better done with Groovy script after the connector execution, but anyway, this is the current situation. For the full-grown connector, I think the best is if the connector is aware of the implication relation, and in this way can extend the implication capability of TCPS. I come back in a minute how this could be done. This is the connector definition input in Bonita. Thanks to the separation of connector definition and connector implementation in Bonita, it is possible to use the same implementation for many connector definitions. Basically, my claim is to develop a single TCPS connector implementation that can be used by process designers everywhere. Of course, beside the decision attributes that is currently the sole input of the connector, rule ID, query data, etc. should be inputted here. And now, back to the implication. Implication can be inputted also very easily, as you see, as a map definition. And of course, you can have more enumerations. Think about the fact that we would have, for instance, approval by 2 persons, 4 eyes, more branches in the process that can be handled this way easily.